Let me move a few little windows around here. All right, so today we're going to cover intermediate Python. As you may know or may not know, if you're just joining us, my name is Burke Squires. I am with NIAID's Bioinformatics and Computational Biosciences branch, or the BCBB. And we have a wonderful website that we're in the process of updating. As I understand it, much of this, the material that is applications and then the research and collaborations, this is going to be pulled into the main NIAID website. And so we're working through how do we update the existing bioinformatics portal here. This is at bioinformatics.niaid.nih.gov. And I would say what's important for you to know is that there are our previous training materials. And they can be found if you click on the training materials link. You will see that we have a number of different categories for the expertises of the computational biologists within my group. And so for our purposes here, if you click on programming and you click under Python programming, then you can see that there are the previous lessons that we've had on Jupyter Notebooks and Introduction to the Programming Concepts, the Python programming language itself, a couple of seminars on data analysis with Python and Pandas, and then finally, last Thursday's data visualization with Python. So if you've missed any of those, you'll be able to, actually, I think I may need to update this one. It looks like I haven't updated, or I didn't update the materials here. Yeah, so I will do that this afternoon, along with the intermediate Python that we covered today. There is also, if you're a NIAID personnel, under the Unix and shell scripting, there was a training that we gave last week that my coworker Pirani gave, in addition to one of the Locus HPC or high performance computing staff. And this is how to utilize Locus. There is a newer high performance computer coming online, I would say in the next year, but that doesn't mean that we're going to be getting rid of Locus for the immediate future. And all of these materials will be relevant to the current Locus and the new high performance computer that NIAID has. So you're welcome to take a look at this. This would require being a NIAID personnel or a NIAID employee, either Fed or contractor, and then being able to get access to the Locus cluster. Okay. We do have some other trainings that are coming up, and the intent is to put them somewhere here on the portal itself, but that is something that we are working out. And so I would say, occasionally visit this, and we will put the upcoming trainings. Those trainings are going to be more scientific oriented, I would say less programming oriented and more scientific oriented. And so they will cover things like microbiome, next generation sequencing analysis. And so if you'll keep your eye here on the portal, that will be a good place to look. As a possible alternative, we do have a, let's see, GitHub. There is a training schedule, and I think this is the older version of the training schedule. Let me give you this. We have not updated this, but you can see here that there is a niaid.github.io/training-schedule. These trainings were given last year, and and so will be added to or have been added to the existing trainings that you find at the portal. So these are all structural biology trainings. So you could look at that. You could find them under the structural biology tab. But this is an additional place. I would say the primary resource is going to be the bioinformatics portal, right, at bioinformatics.niad.nih.gov. But as a possible alternative, if you check the schedule or the link that I just pasted in, that will give you some more information. And then there is a training page, and let's see, that does not seem to be loading as nicely. There we go. This is an intermediate page where we have access to many, and I would say at this point, not all, but many of the repositories for training materials that are available. And so we have it roughly categorized by category, and then it's searchable. And so this is another niad.github.io/training where we have our some of our training resources. But this is just the materials itself. And all of these are duplicated here in the portal, right, at bioinformatics.niad.nih.gov. All right. Well, now that we've gone through that, let's go and jump into some intermediate Python. So my assumption at this point is that you've installed the Python programming language on your computer. We are going to be using a Jupyter interface or a Jupyter Notebook interface, more specifically the Jupyter Lab interface, or that's what you will see on the screen. You can, I would say, simply go to the repository here. Let me find the right page here. All right, and so this is the I would say the working repository. This is my GitHub account, just Burke Squires at GitHub, and in the Python biologist repository. I did just recently update this, so all of this material is also replicated under NIAID's repository. But I would say it is, I find it just a little bit easier to work within this personal repository. Each of these notebook files, the IPYNB or the IPython notebook, each of these you should be able to click on and then have it represented in the notebook, in the web page, and you should be able to follow along with what we're doing, even if you don't copy down the materials. And then what is also really nice is that if you want to, you can open up one of the notebooks, and then we can start a new notebook, and then we can have it to where it displays over to the side. And so, I mean, this is the ideal in the sense that what this allows you to do is to type all the commands. It's going to help you learn them a little faster. But I would say it's a difficult trade-off in the fact that we do have the notebooks. That means that you can go back through the entire material. And so it's, I would say it's a difficult trade-off for me to try and pick how much material to present to you, right? And then if we're going to be retyping every bit of it, then that means that we cut the material in half. And so as always, I would welcome your input. If you think that what we're doing here with the notebooks and then having me explain what is going on, if that is sufficient, let me know. If you would rather have half the material, but then take the time to work through it, and type through it, I would love to hear that. So any of your comments and criticisms are always welcome. So for right now, I'm going to just close this one. And so today, we're going to cover, as I've said, intermediate Python. And I think a few best practices This is a culmination of lots of different material, and I would say it is more specifically tailored towards a scientific audience, or at least that is the intention. In the wild, right, if this was not tailored towards scientists or those who are working in the biomedical arena, I would include object-oriented programming. We can see that it's here, but I would say this is often something that I kind of brush over or ignore unless there is time at the very end, simply because I think much of what we do in our work, right, with as scientists and in the biomedical arena with Python, doesn't necessarily need object-oriented programming. We're not developing, hardcore Python programs for the most part, right? There are going to be some of you who are doing that. I know that some of the packages that I've developed have used it, say, in this realm. So it's not an entirely unlikely opportunity, scenario. But I would say I think there's other stuff that is more important. Right? And then once again, what I have done is I have gone to the GitHub repository. I have gone down towards the bottom. Let's see, go to the main repository. So in this case, it's github.com/Burke-Squires, one word, /Python biologist. And we'll just paste that up here. Right, so that is in the chat. And then you can come along and you can download the entire repository, right, by clicking on the green code button and clicking download zip. But that downloads all of the material and not just today's material. As an alternative, there is a folder with zip archives. And so if you look at the 07 intermediate python.zip, you can click on that. And then in the upper-ish right-hand corner, there is a download option for that zip file. And then you would need to unpack that zip file. And so when you look here, what I have done is I have downloaded the zip file and then unzipped it, and this is the mess that you see. And so I am still working through why there are duplicates. Some are, I think I may have named it cleaned at one point years ago, but I don't understand. So please understand that there should not be duplicates, but there are. And at this point, we're using the notebooks that do not have the word cleaned in them. All right. Let's see. So we have opened up the intermediate Python. And so the learning objectives here, we're going to learn some advanced features of Python, right? And then being able to explain, right, when each of these would be useful in our work, okay? Down on the bottom here, these are some of the resources that were used, right, in pulling this material together, right? I would invite you to take a look at that. I know that I was scanning through some other material recently, and so these may be a few years old, and so you may want to look at some newer materials. But I would say, in large part, the intermediate functionality has not changed dramatically, I would say, in the last year or two. So we're going to start with this idea of packages, modules, and environment. And so this actually I did update, but I don't know that I got the GitHub version of it updated. And so here, if you are, right, if you've been using Python for a while, or if you have attended any of the trainings that we've been giving, then you're familiar with the fact that we are using, right, packages or Python packages that are developed by other people. And those in large part are uploaded to a resource called the PyPI, and that is the Python Package Index. And then what you'll notice is that here in, what is that, early 2020, it had on the order of 228,000 packages. And that number has more than doubled, right, in just the last 3 years. So there are lots and lots and lots of different projects or repositories, or packages in this Python package index. Now, why do I mention PyPI? Well, this is where when you call or go to install a package with the PIP software, the pip software, it is pulling that package from the PyPI or the Python package index. All right. And so now having just under 500,000 packages sounds wonderful. Please understand that any of those or any number of those can be simply a placeholder, right? Somebody wants to create a package, they want to reserve the name, and so there may be nothing in that package. And so, you know, that 480,000 doesn't mean that there are actual packages there. And it certainly doesn't mean that there are 480,000, you know, wonderful, complete, well-documented, tested Python packages. That being said, I would say that there are lots of packages available. You'll notice that almost everything that we use, so pandas, NumPy, as far as I know, they all have, right, their packages uploaded to PyPI. So there are many, many wonderful packages that are available there and that we can make use of, okay? So the first thing, in as much as we've been using the Anaconda Navigator here within these trainings, as you may recall, right, I have installed this Anaconda package, and the Anaconda package is a collection of open source, right, software tools, the Python programming language, the Jupyter Notebook, in addition to many other resources that you see here. And it's a single click installer. So it makes it easy for you or I or anybody, right, to get up and running with Anaconda or with Python and Jupyter Notebooks pretty quickly. That being said, there has been some reworking of their licenses in the last few years, and so this may or may not work in the sense that accessing their, say, Anaconda's repositories at times has been problematic as we're working through license issues, or as, say, NIAID or NIH or any group with greater than 200 employees, as the license states. And so one way that I'm able to work through those problems is if I'm working from home or when I'm working from home, if I have to do an install or an update, that often works well. And that is, if I'm having trouble, like, say, on the NIH network or on, NIH VPN, okay? All right, and so the first thing we want to do is, by default, when you install Anaconda, and Oladell, I'll get to your question in a few minutes. When we install the default Anaconda environment, we see something called the base or the root environment. And then when I open up the Jupyter Notebook here, this is within the base or root Anaconda environment, okay? And for the most part, you may never need to do anything else. You may never, need or want to update your packages. You may never want to create an additional environment, but I would say if you are doing an analysis and it requires specific package versions, or there is any limitation to the package number, so it must be greater than a certain version of a package. If you have any of those types of limitations and you want to create a stable environment, then the best way to do that is to create what is called a new environment. And here we would go and we would say environment. Down towards the bottom, I would say that I want to create a new environment. And so here I would say pi 11, and then just leave it at that, okay? When I create a new environment, what that is going to do, and you can see it ever so subtly here, that in my user folder, in the Anaconda 3 folder, there is a new folder called ENVS, or environments. And it's going to create a new folder within that folder or directory called pi 11. I can create an environment that has both Python and R, or just R and not Python. Although I may not have installed R on here more recently, so it's not giving me that option. And so here, if I click on pi 11 and I create, then what you'll see down here at the bottom of my screen is that it's going to create a new option right under the Environments tab called Pi or PY11. And at this point, what you'll notice is that it has copied the Python programming language, right, version 11, and the pip installer, and a very limited number of other packages that are there by default. Right now, I do not have the Jupyter Notebook installed. I do not have Pandas or NumPy installed. And so if I wanted to make use of this in, say, a normal workflow, I would have to add those packages. And in order to do that, and then similarly to, say, the base environment, right, I can click on the base environment and switch back to the base environment. You'll notice that this option, or this pull-down menu, says installed. I can come down to either all or not installed. And you can see that there are a bunch of unchecked packages. I can also type in here the name of a package. So if I type in BioPython, I believe that is installed. But it's not coming up because it says not installed, right? So here we notice that it is installed. If I click on all, it will also show up. So using this Anaconda Navigator and the Environments tab, this is how I can install new packages. Or if I come down, I'm going to clear out BioPython here. This is how, if I go back to, say, and select updatable, these are all of the packages that are in my default Python environment and that have an update currently available. I don't have to install them, and I would say that I often, right, will update certain packages like NumPy. The programming language itself, right, is available for an update. But I will usually update if I know that there is a problem with the package that I'm having, or if it fixes, say, a security issue or something of that sort. Okay, but this makes it very easy for me to come along, and if I want to update my the Anaconda client, I'm going to click on it, and then I would let's see. Oh yeah, there we go. That was odd. I would click on it, and then down here at the bottom, it would give me the option to apply, and then it would apply or install that new updated package. Okay. Now, so that is the way to create new environments. and then to update packages in the Anaconda navigator itself, all right? A further advantage here is that if I am using, I'm going to click back on my Pi 11 environment. And I'm going to go to all. If this particular environment is one that I have been using for a workflow, and I'm about to publish that workflow, then a major advantage here is that I can go and I can back up that environment. And what this will do is it will create a document that helps me understand or know what is included in that environment itself. Okay. Let's see. And so what you'll notice is that it saves it as a YAML document. And then what is the advantage here is that if I want to go back and re-import that, or more likely, if I want to make this available for others to use, then this document can be included, right, as supplementary material in my publication, and that means that somebody would very easily be able to replicate the entire environment that I used in my analysis just by having this document. Okay. All right, now to get to the question that Oladel had a little earlier. Let's see. So Robert, that's a good question. Can you import a package that is installed in Anaconda when you're in Spider, or does the install package need to be in a local folder? Great question. If you are using this Anaconda environment, what you'll notice is that where is it here? Spider, if I launch it, it's going to launch as part of my my normal environment. Let me make sure that that's correct. So normally, yeah, so here, so all applications on the base or root channel. If I were to go to Pi 11, then what you'll notice is that the Jupyter Notebook needs to be installed, right? Or Jupyter Lab needs to be installed, and Spider would need to be installed. And so I would say that the best thing to do is to go in, and if you're using Spider, then I would install it right within this environment, and then every time you come in and you want to do work on that particular workflow, I would switch to the correct environment and then launch Spider. And then what you do is you're opening up Spider, and it has as its default, right, the folder with all of those packages in it. Okay. I know that within the PyCharm, and more specifically within the PyCharm Professional, right, this is an additional license, right? This is a paid license software. But in PyCharm, you can designate which environment to use for a particular package, and so it does basically the same thing. I do not have PyCharm installed in this particular folder, but I can reference or make use of the Python programming or the Python interpreter in this particular folder. And so then that would mean that I would be using that particular environment, right, for my workflow, right? So, you know, this is, it may or may not be something that you need. Certainly, I would say it is worth looking at if you are going to be publishing a workflow and you want to make it easy for people to replicate what you're using. And I would say, I know that sounds like extra work, but if you consider the fact that you may get 100 questions on which version of the software you're using, it's much easier to export that environment, add that to the publication, and hopefully prevent those unnecessary questions, because you can already answer them, right, and make life easier for those who want to replicate the work to begin with. Okay. All right, now this is all within, right, the Anaconda environment. There are other tools if you do not want to use the Anaconda environment. So here, what we're going to do is we're going to make this a little bit larger. And I happen to know that my my install of Anaconda is in the Anaconda, let's see, my /, that means from my current directory, go to Anaconda 3, go to the bin directory, and then here is where I have all of the software, but I need to CD that. And so what you'll notice here is all of the software, so all of the versions of Python, right? Python is here, so Python is pointing to Python 3.11. I also can scroll up and I can see that pip and pip3 are here. And then also that mysterious software Conda. Let me scroll up a little bit more here. So Conda is going to be here as well. And Conda, as you may guess, is closely related to Anaconda. And Conda is the proprietary, or the installer that the Anaconda project builds, maintains, and utilizes. And so when you install software through Anaconda, then what you are doing by default is you are checking the repositories that the Anaconda project has put together. Now, that's fantastic because they've gone through security checks. I would say you can be, pretty sure that everything is going to work and is secure if you're using the Conda install. And that I would say there's a level of guarantee that is over above the pip installer. Okay. Now, as far as I know, right, the Python package index, right, they go through and they scan all of the packages there for security. But excuse me, the Conda installer, they will do those, right, similar security checks, but then what they also do is that they package the Python software up into a binary file, and so it makes it faster and easier to install than, say, pip does. Okay. And so since we are here in this Anaconda 3 bin environment, so if I type in what is my present working directory, or PWD, we can see it's my user folder, Anaconda 3, and bin. And so here is where I can, type in pip, and let's see. So this is not on my environment, so my bash terminal doesn't know to look here by default. That sometimes the Anaconda installer will put that in there, others it won't. And so I don't know why it doesn't or hasn't done it this time. But here, if I type in the current directory, the period with the backslash and the PIP, this will take me to, right, the pip help. Okay. And then here, I can go and I can say that I want to, right, pip install the BioPython, but that we know already exists. Let me redo it again, make sure I put the little period. Okay. So here it just say that all requirements are already satisfied and everything is done. Okay. I can do the same thing with the Conda installer. So Conda install BioPython, and it should give me the same answer that it already exists. Okay. This, I think it is using, it is trying to install the 1.8 version. And so I'm not entirely sure what's going on there, so I'm just going to exit it. The BioPython, that is something that's no longer in the default Conda environment. And so you can also use other environments. And so let's come back here. Okay. So we've looked at, right, installing stuff for the Anaconda Navigator. With that Conda installer, if I go in on the terminal, the first thing I usually do is I do a Conda update Conda command, and that will give me the current version or the newest version of Conda. If BioPython is not in the what is it, the default Conda repository, then I can make use of other repositories, and so or other what are called channels from a Conda perspective. And so here we see I'm updating my Conda installer. I'm installing, right, a particular package, this BioPython package, and then there is also a project called BioConda, and we will cover this more on Thursday, where a number of software developers or bioinformaticians have gotten together and put together recipes that allow us to install bioinformatics related software using the Conda installer. And many of these softwares are, say, Unix related, and so they need to, or you can install them, say, on a Unix machine, a Linux machine, or a Mac, which has Unix under the hood, but those are not necessarily Windows available. Okay, but we'll cover that in more depth on Thursday. In addition to the Conda installer, there is also the pip installer, right? So the Python package index installer. And so here I'm just simply installing, right, some project. I don't include the text of the project name in quotes, so it really should just be pip install, right, project name. If I need to install a particular version, then I would use the double equal sign with the particular version I'm interested in. And then if I need to give it some direction, but I don't necessarily need to specify an exact version number, excuse me, then I can use something like this where I have in the quotes, right, greater than, I want to install a version that's greater than 1, but less than 2. And so what this would do is this would give me the highest version that is not yet a version 2 of this project. Okay. And then what pip is also able to do is to install from a Git repository. And so if if somebody has developed a package, or if you have developed a package and you have put it in a Git repository, people could go and they could download your code, and then they could run, the Python and the installer file, and then install it on their computer. But I would say an easier way of doing that is if you have the repository where that code exists, then you can do an install directly using pip with one of these, say, these examples. Okay, and so this is really nice. Now keep in mind that right, I would say I wouldn't necessarily do this with just any code. I would perhaps do this in its own environment, unless, say, you are the author, or a known collaborator or something is the author, or it's a well-known package, just because there isn't necessarily any security check, right, if you're doing this type of install. okay? And then lastly, there is the option to install one or more packages using a requirements document. Alper, good question. No, so pip by default is not going to create the environment. And so it would install in whatever environment pip is installed in. And so if pip is installed in the Pi 11 environment and you're calling that specific version of pip, then it would install there. Otherwise, it would probably install in your root environment. Good question. Okay. Excuse me. All right, and so if you have, oh, sorry. If you have many packages that you want to install all together, then one of the best ways of doing that is just to create a requirements document, and on each individual line, put the package that you're interested in installing. And then if there is a particular requirement, then you can follow some text like this, and it will install a particular version, okay? So any questions on packages? So Alper, another good question. Yes, if the package is installed in your root environment, if you want to use it in a separate environment, then yes, you would need to install that in the new environment as well. And there are other, let's see. I would say if you are looking to use environments, but you are not using the Anaconda Navigator, I believe there is a tool, and I would have to look at it. I think it's like ENV, or pip ENV, I think is what it is, pip environments, that will do the exact same thing, but you don't have to install the Anaconda Navigator, okay? Okay, so once we have our environment set up, remember that the reason that we do environments is that we have to have a local copy of the code that we want to make use of on our computers or on the computer that we're using. So if we're going to be running this code on a compute cluster, we would have to install that package, right, one time on our local computer or on the cluster. And then, as we have seen, say, in our data analysis classes, when we want to make use of it, then we call or we import the packages, or they import the modules, okay? So we install them one time, unless we're updating it, but then we call it or import it every time we are starting a new notebook up or creating a new script, okay? And in large part, we have seen this, we've seen this many times before, right? I'm going to be using the word import, right? That is a protected word within Python, and then the name of the package itself. I can install, and so sys is a version or a package that comes as part of the Python standard library. And in this, you can make use of system-related, right, methods or functions. Then you also have something like the operating system, right, that allows you a little bit more low-level, like copying files. And then we have here another part of the Python standard library called time. And so if I'm going to import the three of these, modules, I can do them with commas in between, or I can do them as separate lines, okay? And then here, this is a little bit of an opposite of what we've seen in many of our cases, where we have this sys is the normal way of referring to system in the Python standard library, but here we're using an alias. But in this case, the alias, we're giving it the full name of system. So usually it's the reverse, right, where we're taking the longer name, and then we are converting that into a shorter alias. Okay. All right, and then the last thing down here is just the environments that we have already talked about. Okay, so any questions on package install or module, or making use of your modules? Okay, then I'm going to close this one out, and we'll look next at some documentation. And this is in large part, how do we make use of what are called doc strings? Okay, so the idea with documentation is that as you may have seen if you were with us in the concept class, right, we took pseudocode and then converted it to regular code. So just a second before, so Oladel, your question on when you're creating a new environment and you install the packages, do you need to set the new environment as the path? You do not, but what you would be required or need to do is to use the Python version that is found in the new environment, or say the pip or conda that are found in the new environment if you're doing installs. And then if you're, and then you would want to run, say, the Jupyter, you would install the Jupyter Notebook software there as well. And then make sure to load the Jupyter Notebook, right, from within that particular environment. Okay, good question. And yes, there's one more class, Adrian, on Thursday, which is the bioinformatics programming one. And so if you've registered once, that same registration is good for everything. I think people had the option to check one or more classes, but the Zoom link is the same. Okay. All right. So with regards to documentation, Python is considered, in essence, a self-documenting language. And what that means is that if I am typing out some Python code, then if I name my variables well, right, if I don't use A, B, C, or D, or X, Y, and Z, but I give them names that relate to the actual entities that the information that they're holding, then in large part, right, I should be able to read through my Python code and gather, right, an understanding of what is going on. And so when we talk about documentation, or when we talk about, say, comments, what we're really talking about is if you are making design choices, right, in your code, if there is a fork in the code, those types of design choices are great places to put comments, right? Then what you're doing is you're informing the user, right, and or the future user, right, why there is that fork in the code. Okay. Now, often when we go in and we create our script, okay, this I would say is more relevant to a more traditional Python script than necessarily the Jupyter Notebook, because right in the Jupyter Notebook, as we've seen, I can add whatever, right, text I want, and then below it have my code. And so it's very easy to describe, right, what is the context of my script or the context of my notebook, and then allow people, say, to go down and run the code within the notebook. If I am doing a more traditional Python script, then I want to have, right, some additional information so that people understand, right, what is going on. And in large part, also, if they are requesting, say, help from my script, and they've never run it before, then I want to give them, right, the information that's needed to run it, okay? And so here we're referring to what yet another, what is it, Python Enhancement Protocol, or PEP. In this case, it's this PEP 257. And it talks about how you can have one-line doc strings, right, for obvious functions. So in this case, you put 3 double quotes, and you say return the name of foo, and then you have 3 more double quotes. And what that does is just give you the information on, right, that particular function name, okay? But what we would really like to get to is the idea of having a multi-line doc string that has the following information. There should be a summary line at the top. So here we want to train a model, right, to classify foos and bars. Those are just 2, cute names of 2 different imaginary entities. We want to have a use case if it's appropriate. And so how would people make use of, right, this particular package? We want to list what arguments we're expecting or are settable, right, by the user. And then finally, any information on the return type and then the semantics, unless nothing is returned. And so all of this information should be included at the top of our Python script. And so here I would say is an example, if this is a place where we're defining a class of person, right? This is a simple representation of a human being. And then in here, the parameters are going to be name and age. And so when we instantiate this class, or we create a new person, right, for, say, a classroom piece of software, we would expect that we would have to give a person's name and their age in order to make or create, right, a new person. Now, this doc string is an enhancement, right, over just generic comments, okay? And so in this particular case, what we're going to do is we're going to create a fake module. So my_module.py. And so what we're doing, first of all, is we're focusing on this top line, right, in our code cell. And we want to create a new module. And we want to ultimately, because we want to define a new function. And so in here, we're going to call the write file function. So this is a way that we can get around having to open up a new document, right? I can come and I could come over here, go to the launcher, create a new Python file, paste in the code that I have, and then save it. And that would do the same thing as this command right here, where I'm calling write file with a space and then my module.py. And then in here, I have, right, a single function definition. And then in this function definition, I have the doc string, right, that describes what is going on. So, right, we're doing nothing, we're documenting it. And then because there must be at least one valid line of Python code in a function, we have the pass function. And so if I run this code, what you'll notice is over here to the left, it will create a new Python module, okay, with that function in it. And then what is important is that I can come along and I can say from my underscore module, you'll notice that the py is left off. I can import, right, my underscore function. Okay, and then if I run this, I should get, there should be no error. But now that I have done that, I can come along and I can say my function dot, and then in this case, we use the double underscore, right, or the dunder variable doc, and what that will do is that will return, right, the information in our doc string. Okay. And so what is important here is that if you are writing some code, or let's say that in your particular lab, your PI has stated that she would like the output, to be saved in particular formats, or to be saved in particular locations, or everything needs to be documented and have the individual scientist's name attached to it. But there is specific code, somebody in the lab wraps it up into a module, and so everybody is required to make use of this particular code. Well, when somebody new comes in the lab, or me, if I'm in the lab and I haven't used this module in a month and I forget, right, exactly what the syntax is, well, I can now come along and I can say, oh, you know what, I do remember I have my module on my computer, and I need to see exactly what is the order of variables, or the order of names for paths, in order to save it in the right location. And so I can come along and I can do, right, this from my module import my function, or I can also, right, as we have seen with almost every other, right, Python function, I can import my module, and then I can call the help function, and then it will spit out, right, the help as I am used to seeing in every other, right, Python function. Okay. And so this is something that I would say is, if you are, doing up, or if you're doing your analysis entirely with a Jupyter notebook, then all of this type of information should be somewhere else in the notebook. If you have created a notebook and you're done your analysis, and then either you or somebody else wants to do it in a, say, a pure Python script, then that description, or that information, right, should be added as a doc string to any modules that you may create. Any questions? Does that seem difficult? Does it seem useful? Are there alternatives that you all are using in your lab to, right, document your code? And Robert, so that is a great question. So is a module a collection of functions? Yes. Yeah, and so, all right, as we clicked over here on the mymodule.python. I can have any number, right, of functions in this particular module, or in this Python file. And then as long as I come along and I import them into my new into my new Python script or in my Jupyter notebook, right, then I can make use of them. We do want to keep in mind that if you are distributing Jupyter notebooks, then you are making use of a custom module that you or somebody in your lab has created, right? That module must accompany any Jupyter notebooks that you share. Okay. All right, well, so Nardine, I understand if it looks a little difficult, I would say this is not something that you have to do by any means. And so if you are doing your work within a Jupyter notebook, that's not something I would say I usually do, right? This is only if there are functions or if there is code that I reuse from project to project, then that would be a case for me to wrap it up into my own module and then call it. Okay. All right, let's close these out here and let's look at, we looked at some testing. So I'm going to go over this rather quickly. When we were going through the Python programming language itself, we discussed how you can double check some of your code. And so this, I would say, is is a little bit of a repeat of that in perhaps a little bit more depth. And so there is a philosophy where we should strive for 100% of code coverage for tests. I would say that I don't often get anywhere near that. If I am creating new code, especially if I'm creating, say, new algorithms, then yes, I will go in and test, everything that's possible within that new algorithm and make sure that it is analyzing what it's supposed to analyze correctly, and then give it a few test cases, say, on the periphery, where I know that these particular use cases should fail and I want them to fail. And so what is nice about testing is that all of that can be automated, and then it can be rerun every time I make an update. And then I'm sure that whatever functionality has been added, is still in those in that code. Let's see. And so here, if we just quickly run through these examples. I have this wonderful function called unnecessary math, where I'm multiplying two numbers together. Okay, so we're replicating the multiply function. And so here, what I'm going to do is I'm going to create another test module, So test underscore or using PyTest. And what this is going to do is it has two different functions where it's going to test to see if the multiply of 3 times 4 is correct. But then we're not limited, to testing just the numbers. We can also multiply a letter times 3. And so we're checking to see if that test is valid as well. So I've created my default function, this unnecessary math. And now I have a test function. And what I'm going to do is I'm going to create my my default testing function, and create yet a third piece of Python code, this test unnecessary math PyTest. And that looks like it will, when we run it, it's going to overwrite. And so we're going to look at right, this last version of it. And so then when I call PyTest and I run my test of unnecessary math, what that will do is it will show me that it is running, right, that particular function. And then it also shows me that it passed, right, with 100%. So that one test passed, right? If I want to see a little bit more detail, right, I can call the -v, and then in this particular case, it's giving me which function passed, right? The test of the numbers of multiplying 3 times 4 passed, and I see that here. Now, this is, I would say, a very simplistic example, but as you can imagine, if I can test, right, a particular functionality of my code, then I can run this every time I go to, compile the code or I go to upload it to GitHub. Then what that means is that I am assured every time I upload it or every time I have made a change and I rerun this test, that this particular function, right, the multiplying of the two numbers, that is still working. And so this is something where if you have a workflow and you want to make sure that it will load a file correctly, but that it will gracefully let you know that if a file is empty, those are things that you can test for. Okay. And then the last part here is just this concept of what is called test-driven development. This is, I would say, used more in groups where they're doing, I would say, full-time Python programming. And the idea here is that you write this test to test a part of your code before you actually write the code itself. And then you write the code, you make sure that the test passes, and then once that happens, then you go and you write the next test for the new enhancement of your code, and then you just kind of keep going through in a cyclical manner, right? And then adding features to your code, but only after you have tested it, okay? All right. Let's take a look at logging. How many of you all have ever used logs or logging in code before? Has anybody ever used logs? Charlie, you're right. So if you're debugging your code and you see an error log, then yeah, that is a log that say the Python interpreter is generating to let you know where something is wrong. All right. So logs are great, especially if you have like a scientific workflow and you want to let it run all by itself, but then on occasion, if something happens, you need to know, right, what broke or what went wrong. And so what logging allows you to do is it allows you to add statements to your analysis, and it will let you know when certain milestones have started. So you can set a milestone to say that my analysis workflow has started. I can say that my analysis workflow has ended. If I am reading in a file, I can say that I have loaded the file. And so it gives you some idea as you go, as you work through this, or as the program works through the workflow, that things are working correctly. Now, if everything worked correctly all the time, right, I would say there really isn't any need for logging, but the fact that things, right, things go wrong, then is really where the logging is useful. Robert, I'm not sure, I'm not familiar enough with the Flow.io package to see. You could try just pip install Flow.io, and if that doesn't work, then I would look at the documentation for Flow.io and see if there is a platform requirement or if there is a pre-existing or a prerequisite that may not exist, or you may not have installed already. Okay. All right. So the first thing was, so Python has a logging feature or capability built into the standard library. Right. It's just called, right, import logging. And then what we do is when you log something, you have to create a text file, right, or a log file for the logging to be able to save the information, right, that you want, but you save it separately from, say, the program execution itself. Okay. So what we do is we start off by importing logging, and then we have to do some type of basic configuration. And in this case, we tell it, I just want to save our information to this example.log. And then I tell it what level of logging I want. And so this logging level is where things get very helpful, right, for our purposes here. So we can set one of three different levels. We can set a debug level. That means I'm working on the software, I'm testing things out. I want to see all of this information so that I can help debug, right, the program and make sure that it's working correctly. After I'm finished writing my software, then often I would change my level from logging.debug to logging.info. And the idea here is that it gives me less detail on what's going on in my software, but it gives me enough milestones so that I know that the software or the workflow is executing correctly. And so that would be, I've started the workflow, I'm reading the file, I'm finished reading the file, right? The analysis has started, the analysis has completed, right? And then say my output file has been produced. And then finally, there is this, I would say, lowest level, or the highest priority level, where I only want to see, I want to set it, the logging level, to logging.warning. And in this case, I only want to know if something goes wrong. And so in this case, I'm not told that my workflow is started, right? I just run the software, everything runs as expected, and I only get information out if something goes wrong, okay? So the first thing we're going to do is we're going to run, right, this code, right? And then what I'm going to do is I'm going to create a Python script called mylib, and it's going to just print hello, but in here I'm going to give it some information on logging, right? So we're going to tell it that when this function is called, I want to print out this do something. Okay, so I'm going to run that file, and then that will produce the mylib.py. Okay. And then if I were to call, let's say, so Python my underscore lib, if I run this, I think I need this guy here. right? Then if I run it, then in our example log file, in the example log file, actually, so this I would have to put in here, right, in order for that to work. And so that's why, so down here in our, a little bit, we need some more information, or we have to put in that we want to call, right, this module here, but we have to set up the logging first. And so normally what I would do is I would take this and I would put it at the end here. And then I would, let's see, and then we would resave it. And then what would happen is we would rerun it. And then here is going to, let's see, we don't want mylib, we just want do something. Okay, and so what is happening here is we are, right, running our program, we're running our do something. But when we go and we look at the myapp.log, which is here, we will see that I started the program, I ran do something, and then I finished. And then I would say the advantage of what we're doing in this case is that you can log across different files. So here I can also run, I can define my my code here, my mylib.py, and then I could also call it within the Jupyter notebook. And then we should see that, let's reload this, then it should give us, right, updated information. But I think what it's doing is it's overwriting here. But I would say the take-home message here is that if my code breaks, right, especially if I'm running a long workflow, it may just quit, and the error may go off the screen or something. But if I come to my log file, I could see, oh, here at this point, and if you want, you can also add, say, time information or time and date information in here. You can say at this particular time and date, this do something function, I never got here, right, and I was expecting to, or something went wrong, right, in this step. Okay. So the logging is a way of keeping a track, right, or some record of what is happening in your script or in your workflow. Good question. So Adrian is asking, where do we set the name of the output, the log output file? And when you do your initial configuration, that is part of the basic configuration where you create the file name. And right now we're creating it right in the same directory. You can have it save right to another directory as long as that is working and set up ahead of time. And so what we can do, let's see. So here we've set it at right the warning level. I'm sorry, at the info level. If I come along and I say I just want to do the warning level, then I change my level to logging.warning. I'm going to rerun, right, this, recreate that Python file, and then rerun it. And so now when I go and look at myapp.log, then we should see that there was nothing in there. I know that, excuse me, sometimes when we're doing this in a Jupyter notebook, I think we have to, the file like has to be closed in order to complete that last part, which is a little bit different in the way that, say, the Python scripts in general work, okay? But I would say that the take-home message here is that we can import logging, we can have it create a particular log file. You'll notice here that we are telling it that the process has started. We're telling it that the process has finished, but in the middle here, something else is happening, and we're going through and we're adding some information. And so when we look at our log file, you'll see that it's started, it does something, and then it finishes. So you can see that it's going from this main function, to the do something function, and then coming back. So it's operating as we would expect it. Okay. Questions? No? Okay. Great question. And so that is this if name equals main. This is the way that Python files in general get executed. And so when I'm running this file, say Python and the mylib.py, when Python opens this by default, what it's going to do is it's going to check and see, is mylib running as part of some other larger script, or is this the only script that's running? In this particular case, it's going to be the only script that's running. And so when I run this command here, then the Python lib or the Python's going to come through, and it's going to say that this is the main script that's running right now. And because the name in the background is called, or is the main function, then it will come along here and execute main. If I were to create a new function where I import mylib.py, and then all I do is I'm using one of its functions, the do something function. If I execute do something by itself from another source code file, then Python would say, oh, I am not, or this script is not the main function, and so it would skip all of this information. Now, in our case, we don't want that to happen. So often what you can do is I can put like this type of information. I could put this down here, and then that would allow it to check if it was or if it's the main function, then it would create the config file, or I would want to do this type of creating the logging file in another script. And so I would say this is if you have a Python script all by itself, this is usually some of the code that you include by default. If you're expecting it to run just say by itself, so that's a great question. Okay, well, we are at what is it, 2:30 Eastern. Let's take a 5-minute break, and then we will come back at 2:35. Okay, any questions on logging or anything else? So the main function and the name underscore, that would be a good thing to add to a future version of this. Okay, and I'm going to close that one down. All right. Now, if you are creating your script, I would say this is another thing where it's going to be more tailored towards pure Python programming. It, of course, would be useful or could be used in the Jupyter Notebook. But the idea here is that if you have a Python script and you are creating an entire analysis, or you're running this entire piece of code, and there are different possible options, how do you allow that, or how do program scripts in general allow that? And so if I come down here and I see that I want to create a script, in this case, I want it to be able to tell me, we're going to pretend for a moment that I am creating some script that has to do with some computer networking. And so I want to be able to set a username. I want to be able to set a particular port and say the IP that somebody may be doing some work on. So if we think that we're recreating a file transfer FTP software, or we're trying to recreate the the SSH program, where we would transfer files securely from one location to another, they're going to need to have information on what is the IP address that we want to attach to, what may be the port that we want to attach to, and we would need to have some user information, because we need to make sure that the user has permission to be accessing that particular website. And so this is using a module called argparse, or argument parsing. And the idea here is that we would create a script, and when we run it, we can, let's see, so we're going to run this script here. We're going to run this cell, and as you may recall, we're going to use this write file magic code to create a file called arg.py. Okay, so then this will load and look exactly like the code that we see here. Okay, and what we are going to do is, if this program or script of ours existed, and as we looked, or we talked about before, when we were looking at the docstring information, this takes that idea of the documentation of the docstring to, say, another level, where we can not only get some information, but we can actually make use of the information that the user or we would add if we're executing this on a command line. And so the first thing that we would do is we would call our script, just the exclamation mark just means that we're going to send this out to our bash terminal, and we're going to run the Python interpreter, and then we're going to input this file without any information, without any arguments specified. And when we do this, we see, that there is some usage information, we have to type in the name of the program, so arg.py, and then there are 3 different options, this -h for host, the -p for port, and the -u for the user. And then we see that we have an error in that there is a required argument of the host, So the next thing we're going to do here then is I'm going to import a mock host address, This would be an IP address that I would want to connect to. And so now if I run this, then we see that what is happening is that the right, we have given it a particular IP address, and then look at this, right? The output here means that we have been able to read the IP address correctly as an option for host, and we pulled that information out of the command line. Now, where did this other information come from? Anybody want to take a guess? Thank you, Oladell. So what you'll notice is that we didn't specify, right down here, it's saying that we need to specify a dash P for port and a dash U for user. I didn't specify either of those here, but somehow it picked up that the port is 8080 and that the user is root, which I would say is, as a default, is probably the world's worst default, because that the root user has many more permissions. But what you will notice down here is that in the user argument, there is a default of root, and then in the port option, there is a default of 8080. And so this is just gives you some idea of what is possible. Right, when I am using this arg parser, this argument parser, I can tell my script that there must be, that something must be required. So here we have required equals true for the host. You'll notice that that is not the case for port, and it's not the case for user. And so if I set just the IP address and nothing else, then it's going to use the default for the port and for the user. I can come along and if I need, let's see, so I can call for more help, and this will give me a little bit more information here, or I can specify that the port is 8888 and that the user is me. Okay. And so what is nice about this arg parse module, you'll notice that we're importing arg parse here. This is a module that is once again part of the Python standard library. And what it will do is it will go through and it takes the system arguments. That means that it takes everything after this first name and parses it out. And then we're using these add arguments options will match the particular abbreviation to the particular argument. What is really nice here is that if you have a script and there are a number of it's talking about, say, forks in your code, there are a number of different options that you need to allow for or to accommodate. Creating your script and then adding this information allows you to make your script much more flexible and usable, say, for yourself and then for anybody else who may use the script as well. Okay. Any questions at this point? Let's see, I think there is one other example. Yes, so we have created right? This arg.py file, if we look at that, you can see that this has the argument parsing in it. So normally, right, my code would be up here in these lines. And then this is that same, double underscore or dunder name option. And if it is the main script that's running, right, then it will match name will equals main, and then it will parse the arguments. Otherwise, it would just skip, right, all of this information together, which is great because I can make my script and I can add these options as main. If I need to run it from the command line, then it will parse the arguments it needs. Otherwise, I would just call whatever function is up here and execute it that way. Yes, Lothar. So if you wanted to, we've seen the range function before, right? That's built into the standard library. And if I wanted it to be a non-zero index, then yes, then I would include, if I wanted to do it from 1 to 200, I would do 1,201, right? So we would just shift everything over 1, okay? Or you just do range 200, and then you can add 1, right, to everything. Good question. So in the argument parser, So it depends on how you would want to do it. You could request a minimum, and you could request a maximum, or you could ask for a range and then put in there the 2 brackets, right? So here I could say that the default would be 1,200. Let's see. Right, 1,200. That could be the default, and then I could ask that you put it in here like this, and then you would have to do some checking to make sure that people aren't accidentally putting a period, that they're not accidentally putting lots of space in there, because all of these would be, the script would run, but it would need a little bit more finesse, or a little bit more double checking. If that's the case, then it may be easiest to put like S for start, and make that just the number 1, and then the end, and then make that equal to 200. Right, or actually it would be, I would say it's going to be represented as a string because you're working on the command line, and then you would need to convert that once you get into your program. Right, so good question. So you can do it. I think I have a script where it is doing something like the brackets and includes a bunch of numbers, and let's see. Let's see. And so in here, there should be some checking. So here I'm looking for positions. It's not in brackets, but they do have the option to put a dash in there, so they can give a range of, say, 100 to 110, or any combination of a range and then individual positions. And so this, you can look here. This is a what is it, like sequence feature variant type, or a it looks for sequence features and then the different variants within it. That was a code you can take a look at. Okay. All right. And so this is, so I would say in this example here, right, in this FIVAR, this is a script that I've put together, and it can be run from the command line. And so it would give the person, or the people using it, the option to set command line options, and then have them parsed and then run the code. All right, great question. And I would say, and so the information here, the take home is that you can have, there is great flexibility, right, in what can be done. So we're going to try running, let's see, we'll run this arguments2 here. If I run arguments2, I can see that there is this n option, right, to grab different integers. And then here, right, I can input the integers 1 through 5. Or if there is a wrong integer, right, or if there's a number that's not an integer, then it can validate it, right, and then give you an error. So this this argument parsing, this is just a longer example where you can see that there are there's a lot of capability within, right, this module itself. And the idea here is that you want to give as much flexibility you can, but also do as much checking, right, as you can before you start running the code itself. And so you want to make sure that that the code, right, will run, do what you expect it to do, but that if somebody imports a wrong function, then it would catch it. Okay. Other questions? Right, there are other packages. So argparse is one of many different packages that does the argument type parsing. There are external packages, so these would have to be installed on your computer, right, at least that first time. So click and fire, and then there is this document options, and that is part of the Python standard library as well. Okay. So for the time being, as I mentioned, I'm going to skip over the object-oriented stuff. Something that you may encounter as you go through and you're looking at code, or if you're using particular packages, are called decorators. And this is, it's a wonderful way of being able to write Python code, but I would say it looks very different than, say, your standard Python code. And so the decorator is where at the very top, or the line immediately preceding, say, a function, you have the @ symbol, and then that @ symbol calls some other function. Now, often this function that it's calling, we don't see it. This is, say, an exterior package that we have imported. If you are trying to do some parallel code, I'm trying to think if it's Desk that runs this way, where you can use the decorators. But this is something that is becoming, I would say, more and more popular. And so you may encounter it. And so I wanted to, bring it to your attention and give you some idea of what is happening. And so here we have some code, right? We have a module that is a decorator module. And you'll notice that it's called logit. And as its input is a function. And we see that the second part of this, it tells us that this function logit, it wraps around the function that we are using right in the parameter here. And then what is going to happen is I'm going to take a function that has no logging information on it to begin with. If I decorate it with this logit decorator, then it will execute that function, but it will create some log information beyond or outside of it. And so here, if we run this, so our default, or really the only work that we're doing in this particular cell, is we're calling the addition function. We're creating the addition function, where I would take some number and then add it to itself and then return it. Okay. And so then here we should be able to say down below, right, just print out my result. So I run my function with the other function that has the decorator, that creates the decorator. If I run the decorated function, then what you will notice is that it is outputting, right, that the addition function has been called. And then if I go and I print out the result, right, we should see that the result is 8 as it is, right? So it's a very simple example, but I would say simple but powerful. And so what is happening in this case is, before this code is run, the function or the decorator is running a piece of code first, and then running that function, and then everything exits. And so this is a great way of executing, say, two functions at one time almost. The possible downside here is that it can make it difficult to understand exactly what's going on. So if we have imported, right, a package that has this logit function in it, and then all we see in our code is this, that's a little bit of a black box, right? And so that would say that in some sense goes against the idea of making Python easy to read. But if we understand that the code that is used for the decoration or the decorator, that is something that we would have to be importing, right, or adding to our system, odds are that what is going on behind the scenes. Okay. Any questions on decorators? Robert, I'll get to your question in just a minute. All right, the difference between a module and a class. A class is something that is part of the object-oriented programming paradigm, and it is something that starts with the word class. And so in large part, let's say a module is really a file that has multiple functions in it. I would say the module can include classes, but doesn't have to include classes. When we have come down here and we have created these different Python scripts, we would say that these are modules and that they contain functions. These modules could also include classes, and a class is it's similar to a function, except that it has its own memory and is part of that idea of the object-oriented programming design. Okay. And so then you have yeah, and then the difference we would say is between like a function and a method. The function is going to be outside of a class, and then the method is the same thing, but say inside of a class. Okay. Let's see. And so does the @ symbol cause it to jump? So the @ symbol is where it good question. And so I would say the particulars of how it is working. We have to put the decorator right at the beginning of the function that we're interested in decorating, and it appears that before this function is actually called, the decorating function is called first. Okay, so let's see here. If we do print of this, and then this will give us a little bit of a better idea. Right, so here what is happening is we're running the decorated function first. That's how we get this information, and then we are running the function that is decorated. Okay, I think you can reverse those if you want, and so it may be that I'm not sure. I'd have to look at the documentation, but I think you can reverse those as well. Or you can do both. So you have a lot of capability with decorators, with the desk? I thought I must be wrong, darn it. There is a, let's see. So dispatch, celery, click. I am not sure. I know that there is a particular function that allows you to optimize your code, but it uses the idea of decorators behind it. But I don't see where it is. No, but I would say the take-home message is that we want to understand that if you see something like this, right, that the @logit command it's technically outside of the function, and so it's not part of the function, and it would be tempting perhaps to put like space in between it, right, to make it easier to read, but it is a decorator and must occur right before the function that it decorates. And so if you see this, then you would know that, right, something else is happening just outside of this particular function. Okay. All right. So as you may recall, when we were talking about some of the many benefits of Python, one of those is that Python is considered batteries included. And so if you are not familiar with that line, it means that, and certainly when I was growing up, when you had toys, if a toy was supposed to it utilized a battery, often companies did not put the batteries in the toys to begin with. And so it was a major selling point of some toys that required batteries if the batteries were included, right? That means that mom and dad didn't have to go and right, find them in a drawer or purchase them separately. And so Python is considered batteries included, which means it comes with everything you need to do, right, an immense amount of work. Okay. Some of the more, so there are, I think it's 300 plus packages in the Python standard library. We have seen, right, the date time module, and this is the module that allows you to work natively with dates and times, but we were using this to convert columns in pandas. There is this oddly named function or module called glob. And glob is a fantastic tool that returns a list of files with given extensions, and it allows you to very easily process, right, an entire directory of files and say only process the files that you're interested in. So if you want to process a directory that has both, say, PDFs and CSVs, glob will allow you to quickly get a list of the CSV files that you can then use and run through and analyze, and not have to worry about getting or misreading any of the PDF files. There is a package called iter tools, and this allows for some advanced functioning and operating on lists and iterable objects. And iterable in this case just means that you can process through it in a loop. And iterable objects are everything from lists to files, right? Or anything that can be made to loop over. There is a multi-processing module within the Python standard library. And what this allows you to do is to distribute your code across multiple processes or multiple machines if you need to do some parallel processing. There is an OS module And this allows you to work with the underlying operating system, whether it be Windows, Mac, or Linux. You can use this if you are trying to work with some files or if you need to get some path information. This shutils gives you some high-level file or shell operations. And then sub-process allows you to run essentially command line statements, but within the Python context, okay? In addition to those other files, there is a module called collections. And one of the, I would say, more interesting things in collections, there used to be just dictionaries. And so a dictionary is something that has the key value pairs, as you may recall. And one of the major, I would say, downsides, or one of the questions about dictionaries in their original form, is that you could recall the data very, very quickly, but you didn't necessarily know in what order the data is in that dictionary. And so that could be a problem if you wanted to loop through the dictionary, then you weren't sure what would be the order. Nowadays, and I believe it's part of the collections class, there is something called a default dictionary, or default DICT. And that has all the advantages of the dictionary, right? The key value pair and the quick searching, but it also is addressable, or it is put together in a particular order, right, that you can make use of. Right? There is something called a named tuple, or named tuple, and so in order to use something like this, so a tuple is a collection, right, or a set that cannot be changed once it's been defined. So it's an immutable object. That means you cannot add, append to it like you would a regular list. And so instead, you would have to entirely recreate it in order to change the tuple. Okay? A named tuple allows you some additional, right, functionality here. So here we're going to, right, create or import named tuple from collections. And now I'm going to create a named tuple called features. And it is, I would say, the way that I see it is, it's almost like a lazy way of doing object-oriented programming almost, where here I am creating a named tuple, but it looks very similar to what a class and a class instance would look like. So here I'm creating this variable called features. It's a named tuple, and it's going to have, right, an age, a gender, and a name. And so if this was to keep track of students, I would be able to create, right, this new student, right, called Alex, male, and he's 22 years old. And then if I wanted to, the advantage here is that I now can refer to, right, a student's age by calling this age parameter, even though nowhere in this code did I define, right, an age function, or say an age parameter. So this is it's a very interesting way of creating or managing, right, information, and then being able to recall it by, right, the type of information, or the variable of the information itself. Okay. Right, let's see here. Now, this counter function is a part of collections as well. And what this does is this allows us to do some almost like metadata counting or some tallying very, very quickly. And so I'm going to call, right, the counter function. You'll notice that that is a capital C, right? So from collections, lowercase c, import counter uppercase C. I have a list of ages, right? And then I'm going to define, right, my counter object. I'm going to call it value underscore counts. And then that value underscore counts gives me the option to pull up something like what are the most common combinations or the most common values. And so here I see that the age 22 occurs 5 times, right? The age 23 occurs 3, etc. But if I look at what are my options, I can see that I can get, right, different keys and the items. I can get, right, different elements. I can look at what is the total. I can do some updates or grab the values out of it. Okay, and then I can also, pop items, say on and off. And so it gives me, right, some capability that I don't have otherwise. Oh, actually, so here is the default dictionary. I'm so sorry. So the default dictionary, right? This is where we previously did not know the order that things were in, but now not only do we see that there is an order to it, right? So it's actually in order, but I also have the option to call. So here, if I look at my default dict, and I say I want to see the T's. Let's see, T, right? Then I can see that there are 3 T's in this statement. So it allows me to take advantage of all of the capability of the dictionary itself. But now I have the advantage of also having it arranged, right, in the order that things are added. Okay. Any questions on these different aspects of the standard library? No, Robert, so good question. So the default dictionary is not a string. It is still a dictionary, and you can do everything that you would with a dictionary. You can add to it, you can, but now what you do is you have the option, or you can see now that the dictionary has an order to it that it didn't have beforehand. Right, so now if I want to refer to the third item in the dictionary, right, I can refer to the third item in the dictionary, but beforehand I was not able to do that. It's a good question. Okay. Here, what we're looking at is just the current version, the 3.11.5 version of the Python standard library. So recall that anytime that you install Python, the standard library comes with it. And so you can see that there are a large number of functions, constants, and types built in. There are text processing services. There are binary data services. There are different data types, such as the date time that we've seen in the collections. There are some numeric and mathematical modules. some other functional programming modules, such as the iter tools that we saw. There's information on dealing or working with files and directories, data persistence, data compression, different file formats, cryptography or cryptographic services, and then some generic operating system contexts. So you can see then networking and internet data handling. And so there is a large repository of information, right, and capability just within the standard library itself. Okay. Right, let's touch upon some best practices. And this is a collection of some advice from a number of different options or number of different sources, right? And you can just read, right, the information here. When possible, right, follow the PEP8. That's one of the first particular examples. And as you may recall, PEP8 is the way that you format Python code. Understand that the code that you receive is most likely going to be, right, formatted in PEP8. The code that you see in examples is most likely going to be formatted with PEP8. And so if you are planning on, ever sharing your code, then it would make most sense to format it with the PEP8 guidelines. And then that way it's easily shared, right, amongst people. Those guidelines include so variables, functions, methods, and packages and modules. They use this lowercase with underscores between words. If you are using classes or exceptions, those have each word capitalized. If you are working with protected methods or internal functions, they have a leading or a single leading underscore. And then if a method is private to something you've created, as we saw with like the version information, that has 2 underscores in front of it. Okay. And then finally, constants are created with all caps and then underscores between the words. It's recommended that you avoid one-letter variables, right, such as X or L or O or I. And then in here, the exception is if you have a really short block, then it would make sense. And so if you are doing something like this E in elements, then the elements, the E, I would say, makes sense, right, in the fact that it's the first letter of elements. We want to avoid using redundant labeling. And so instead of doing something like this, where we would, so if you're creating these methods, and I was creating an audio package, I would not want to call my methods audio core, because audio is already going to be part of the package name itself. And so then what would be the preference would be to, right, refer to each of the functions, right, by their usage, say core or controller. And then we would understand that when we are importing the package, right, that this is an audio core and that this is the audio controller. Okay. And then if you are naming multiple functions, or you have multiple variable names, if they are related, so here we have elements, and then we have both active elements and defunct elements, it is better to use what they're calling here is this reverse notation. So keep this common portion of the variable name first, elements, and then add on to it, right, something more descriptive, as opposed to say elements and then active elements and defunct elements, because as you can see here, the idea is that it's much easier to read and then relate, right, these three variables than it is necessarily to relate these three variables. And then in those cases where you're using getter and setter methods, now this is usually if you are coming from another programming language where you put or you create getter and setter methods. With Python, the preference is just to simply use the property name, right, as the function name. And so here we would set age to be equal to 42 instead of set underscore age equal 42, or b, and then 42 as a parameter. With regards to imports, the preference, and this is right, we're continuing with the idea of the PEP 8, is that we would start with a broader implementation, and then if we needed to, then we can drill down into portions. So here, if we want just the sessions portion of Canteen, we would call canteen.sessions, or we can also use the from Canteen import sessions. Okay. And then comments we discussed. So this is a great example of if we are using, or if we're giving our functions informative names, then instead of saying if the sign is a stop sign, and then we would say if the color is red and the sign is 8, then what I would do is I would define a new category, or a new function, is stop sign. In here, I would check to see if those two qualities are being met. But what you'll notice is that when I go to call that function, if it is a stop sign, is easier to read, then trying to figure out what you're getting at with this combination of information. Okay. The recommendation, there's usually a recommendation of, say, limit yourself to a certain number of characters per line. The recommendation is that if you have, say, between 80 or 100 characters per line, that is fine. And then in this particular case, that you can use parentheses for line continuations, as we've seen in some of our functions, and that will auto indent for you. Okay. And then there is more information here towards the bottom. Good question. Can you use the triple quotes? Let's see. I am not sure. So here we want, if we're thinking code, It does, let's see, is that, it doesn't look like it necessarily is, it doesn't like auto indent, but it does look like it will cover. Yeah, so it looks like it works, but it doesn't do right the auto indentation for the longer lines, right? Okay, very cool for putting in PDFs. Yeah, I mean, you could put like an entire header right there. Okay, very cool. I like. Right, for creating reports or something like that. That sounds great. Okay, let's see. And then the quote unquote perfect project setup is an interesting little find. And so part of this are, you know, what are some good practices? There is a package called Black, and Black is a popular code linter or formatter. And so if you, so I would say often what people will do is they will format their code or they'll run it through Black before submitting to GitHub. And then the idea is that the code in GitHub then is as best formatted as possible. And so then here are some ideas on how to set up if you have a setup configuration that you can do that. Let's see. So if you are, you can use pip to install the pip environment. And if you recall, the pip environment is something that will allow you to create the environments similar to what we were doing with the Anaconda environments before. Flake 8 is a nice way of formatting your code as well. So people will often combine, say, Black and Flake 8 to do your to format the code before, especially before you submit it to GitHub. And then something that has come out more recently in some of the Python languages are with static types. And so I don't know that I've seen it much with my MyPy, but in newer forms of Python, you can do static typing, which is you are telling Python what type of values are you expect in your variables. And so it's similar to, say, something like a C++, you know, or some of the compiled languages. And so let's see here. And so if I was defining, you know, define a function called addition, I could put in here that x should be an integer and that y should be an integer. And I'm trying to think if it goes, I'll look in just a second, but I think it should output to an integer. And then we would say return, x plus y. Let's see if that works. Oh, let me see what the code is. or I'm sorry, type hints is what they're called. And here we go. So it's just the and so this is something that they're, I would say, they're beginning to implement. And the idea is that it makes it easier if you're like pre-compiling. And so then in this case, normally we would write, let's see, right? The traditional way of writing this function is like this, right? X and Y. And they both work right the same way, but the type hints, I think some of the packages can make use of the type hints to help with compilation or with compilation, right? The dreaded function colon. Sure. So Robert, I think what you're asking for is, let's see, so returning variables, right? When I return the variable here, I don't have to put the parenthesis. I think just by common practice, I can do it. I can also put in here, I can return, right, multiple things in Python, which is one of the things that I really love about Python. And so here we can say A, B, and C equals this. So here I'm going to document this out. So I can, right, I can take two numbers in, right, this X and the Y. I can return more than one item at a time. And this is, I was saying, it's just a very fast and powerful technique if you want to make use of it. And so here we should be able to, let's see, print A, print B, print C. And so here, what is happening is we're sending in two numbers, right, 3 and 4, but I am returning more than one value. In this case, I'm returning 3 different values, right? The 2 numbers that went in, and then the addition of the 2. And then this is really where you see the power of it, is that in my Python statement, I can capture more than one output, right, from a particular function. As long as it's sending out more than one, I can return it. I also can put an underscore to ignore that information. And so I think B just means that it's in, let's see, I don't know that it stores it. Maybe it does store it, but it usually it's a way of putting in a placeholder to ignore it if you want. Normally, if you needed to do something like this, I would have to take this information, I would have to go through the extra step to include this in a list, export that list as a single data object, and then I would have to take apart that list to get at the individual elements. And so that's just extra work that's not necessary when I can output however many number of items I want and grab them, right, and then start immediately making use of them. And then as we saw in the defining function, I can put in here, right, that by default, X is going to equal 1 and Y is going to equal 2. And so I can call this and it will, right, utilize those defaults. Or I could override, right? So by default, if I were to just type in one number, then that should override just the first item, unless I set it equal, right, to the other number. So in this case, I'm explicitly telling, right, my function that I want y to equal to 1, and then because I am not specifying a value for x, it's going to use the default and then would add them together. Okay. Good question. Let's see. We saw the information on testing. And I think this may be a little bit dated. This is where you can do some work in, Git before. So if you want to run Black and Fleck 8, I think this is the previous version. That has not been updated for some of the actions. Okay. Robert, I can deal. We can look at that. I can do that at the end of class, or we can try that at the end of class and see. And if you are creating a package on, let's see. So if you're creating a package, there is a function called cookie cutter. And what cookie cutter allows you to do is to take a template of a new project and then make a copy of it. And then it would go in and create and then set some defaults for you. Okay. And so let's see if there is a good example of, well, so here, this is, I think the project itself, right, is an example of cookie cutter. And so you can go in and make a copy of this, and then it will set up everything so that you're ready to test with PyTest. It would automatically format your repository with Black, and then run the linting through Fleck 8, and then deploy to Docker. So all of this would be set up for you if you were to run or use cookie cutter and then this, right, best practices template here. All right. All right, and I think that is it. Let's see, the last thing is something like Python. So I don't use this a lot myself, but this is there are other ways to take your Python code and then have it optimized or pre-optimized. And so one example of that is to make use of Python. Let's see if we can find an example. So as I understand it, what this allows you to do is to just basically take the code that you have, run it through a different optimizer, and then it can optimize the code, right, without really having to change anything on your end. So I would say, if that sounds interesting, I would look into something like Python. Okay. And then with that, right, we have covered what I think are the important parts of intermediate Python. So we've looked at a bunch of different stuff, right, about, say, packages, modules, environments. We covered a little bit about some right, documentation and testing and logging. If you have questions or suggestions on what could be included in this in the future, please let me know, and I would love to evaluate that particular material. Does it? I'm not sure if it compiles for Windows. I want to say naively, I think it does, but I would have to look at the documentation, Robert, and see. I'm not sure. I know that, I mean, Python, you know, it can run on Windows if you have the Windows version of the interpreter. And I would unsafely say that Python has a Windows version, but I would have to look at the documentation. Okay. All right, well, with that, let me type in my email address once again. And if you have any questions or comments on how to make the trainings better, I would be happy to hear them. All of the materials will go up on the bioinformatics portal, right? And then there you can also stay in tune with other trainings that we post. And then I look forward to seeing you on Thursday for our final training, where we're going to look over some bioinformatics programming and workflows. All right, thank you very much. And so, Robert, let's take a look for a moment and see. So it says it has 0 external dependencies and requires Python 3.7 or later. And so this should be, right, the way of importing it. And so here, if we go and we look at our environment, and we, let's say we'll pick Python the 3.9 version. Let's see, I don't know if the index, I don't think that would catch it, because I think this is only through Anaconda. And so here, if we go, there should be an environments folder, right? So envs. And if I list this, it should show the 3.9 and the Pi11. Right. So if we go to the Pi 3.9, and if I list everything, then it should show the bin directory. And then in here, there should be, right, the versions of Python. Right. So Python 3.9, there should be a version of pip. And so then if I come along and I type in, right, pip install, let me see, I think I copied and pasted, make sure we're, so pop install. So it looks like here it's using a capital F and a capital IO. And as long as I am using, I would say it probably is trying to match the capital F and the capital IO. It looks like it is installing, right, with no problem. And so it says that it's, right, successfully installed Flow IO 1.2. All right. Well, have a great afternoon, and we will see you on Thursday.